Hello, 7th grade. Today we are going to be talking about something brand new that is called a sequence. And sequences are kind of fun and fairly easy to understand. So I'm going to jump in with an example, and then we'll define exactly what a sequence is. But an example of a sequence would be 3, 6, 9, 12, and so forth. So this is a sequence because there's a bunch of numbers in a row, and they all follow a pattern. So I could continue this on forever. Next would come, 15, 18, etc. But I don't really want to do that. So I'm just going to write the first few terms and call that my sequence. And some things that we know about sequences is that they are a list of numbers that follow a rule. So they are a list of numbers that follow a rule. And there's really no limit to what the rule can be. So we'll see some different kinds later. But we're going to start off with this thing called a arithmetic sequence. So what an arithmetic sequence is a sequence where the rule is just adding the same thing every time. Arithmetic sequence means that we are adding the same amount every time, so there is a constant difference between terms. Set amount between numbers. That's how I'll put that. So every time if we look up at our example, I'll go from one term to the next, we're going to add the exact same. 3 plus 3 is 6, 6 plus 3 is 9, and 9 plus 3 is going to be 12. So we know that this right here is not only a sequence, but is an arithmetic sequence because we add a set amount or the same amount between numbers. And we will keep on going here. I want to show you guys an example real quick. If you know that you have an arithmetic sequence and it starts with 1 and 5, then because you have to add the same amount between each, you added 4 here. So you would keep on adding 4. You have 9 plus 4 is 13. So as long as you are adding the same amount every time, it is still an arithmetic sequence. And if you're told that, you just find the difference, you keep on adding it, and you are good to go. There's one other kind of sequence I want to talk about, which is called a geometric sequence. And in geometry, we don't really add much, and you'll see that in about 2 years when y'all take geometry. But when we're doing a geometric sequence, we don't add the same amount every time. We multiply by the same amount every time. By a number each time. So what that looks like, my example here is going to be like if I start with 2, I can multiply that by 2 and get 4 to 8 to 16. Or I could do it by 3s, and I would have 2 times 3 is 6, times 3 is 18, times 3 would be 54. And I'm going to leave that there before I can't do the numbers in my head quite so fast. So long as you're multiplying by the same number every time, it counts as a geometric sequence. Something else that might be interesting is technically multiplying by fractions is still multiplying by numbers. So another geometric sequence would be one where it halves every time. So if you have 1/2, 1/4, 1/8, 1/16. This would keep on halving every time, and that would give us a geometric sequence because every time we are multiplying by 1/2. Multiplying by 1/2, which is the same thing as dividing by 2. Whatever way you want to look at it, it will work. So what we want to be able to do is write formulas that describe these things. So if we go back to my arithmetic sequence, these formulas are normally pretty easy to write. If I write a formula for an arithmetic sequence, let's go back to our very first one. I had 3, 6, 9, 12. And what I want is to be able to know what my number is. So I'm going to say each number here is A, and based on what position it's in. So this is the first one, this is the second one, this is the third, and this is the fourth. And just a quick note on how we're going to write these. What this means, if I put A, and then this is sub 1, so I'm writing a little 1 underneath the A, I would pronounce that a sub 1. That's going to be the 3. So a sub 1 means my first number is 3. A sub 2 is 6. That means my second number is 6. And a sub 3 equals 9, and so on. So what we want to do is to be able to write a formula for this. So I can have an a sub n, and then I can plug in the n and figure out what the number is. And I want to be able to make a formula. So what this ends up looking like, if I have a sub n, what I need to do is to have, to get 3 when I plug in for 1, to get 6 when I plug in for 2. So every time we have an arithmetic sequence, we're going to have something times n plus something else. So we're going to start just by knowing we have to multiply by n. So something times 1 should give me 3. Something times 2 is 6. Something times 3 is 9. And what that's going to be is 3 times n. So a sub n equals 3 times n. If I plug in 1, a sub 1 is 3, a sub 2 is 6, a sub 3 is 9, just like that, and we are good to go. So looking at a bit of a harder one, if instead of this I have 1, let's do 4, 7, 10, what I'm going to need to do, this is a separate example here, to find my formula is every time I'm still going up by 3. Up by 3, up by 3. And if we noticed up here when I went up by 3, this number was 3. And that's going to be a general rule, is whatever we go up by, we're going to multiply by. So I have a sub n equals 3 times n. But that doesn't quite work, because if this was it, we'd have the 3, 6, 9, 12. So I have to figure out something else to do. So every time here, I have 3 times n. 3 times 1 is going to be 3, but I should have 1, so I'm going to subtract 2. And here, 3 times 2 is 4, or is 6, and 6 minus 2 is going to be 4. So our general rule for how we're going to do this is we're going to start by trying to figure out this number, and this number is always going to be the same as the amount we go up by, and then I'm going to add this on just to kind of correct it in there a little bit. So one more example, just for good measure. If I have 1, 3, 5, 7, 9, what I want to do is start by figuring out how much these go up by every time. And if we look, 1 plus 2 is 3, plus 2 is 5, so it goes up by 2. So I'm going to take this number and say an equals 2 times n. Then I'm going to see what I get from that. 2 times 1 would be 2, but my first number is 1. So to get from 2 to 1, I have to subtract 1. Now I have a sub n equals 2n minus 1, and that's going to be my formula. One last thing that I want to be able to do is a formula for a geometric sequence. So we're going to do geometric formulas now. Geometric formula. Technically, the plural of formula is formulae, which is kind of weird, but that's okay. So for a geometric formula, we're going to have something that looks kind of like a sub n equals a number, I'm going to call it k to the power of n, which is going to be kind of strange, and that's okay. We'll make it work, and then this is going to be multiplied by some other number. Let's call that c. I like the number c. It's a good number. And what we're going to do here is I'm going to pull up that first geometric one we did, which was 1, 2, 4, 8, 16. If we look, every time here we multiply by 2. So what that's going to mean is an is going to equal, this 2 is going to be the same thing as the k. So we're going to have 2 to the power of n times c. If I have a 1 first, 2 to the power of 1 is 2. So I have 2 times something is 1, so c would have to be 1/2. So an would be 2 to the power of n times 1/2. I know that's a little bit confusing, so we'll try another example just for fun. And what we end up here, we'll try, let's do 6, 12, 24, 48. So if we look, every time here we're still multiplying by 2. Times 2, times 2. And I told you all we would start with an equals whatever we're multiplying by, which is 2 to the power of n. My first term here is a 6. 2 to the power of 1 is 2. And to get to 6 from 2, I would have to multiply by 3. So in geometric, we're going to be multiplying here, which is a little different from our arithmetic formula where we add at the end. If I go all the way up, we add here at the end or subtract. But for the geometric formula, we're going to be multiplying. So 2 to the n times 3 is going to give you the 6, 12, 24, 48. As a quick review from what we talked about today, hopefully we'll be able to figure out arithmetic and geometric formulas. Arithmetic, add every time, and geometric, multiply. Arithmetic formulas also look like a sub n equals something times n plus something else. We're going to do k times n plus c, whereas geometric formulas have a to the n equals k to the power of n times c. And that's kind of the generic formula that we want to look for, where this is how much we add every time for arithmetic, and this is how much we multiply every time by geometric, and then the c is just what we use to fix it, to get it where it needs to go. In any case, please look at the practice set. There's about 8 problems there. None of them are making your own formulas, so it should be fairly simple, easy to go. I know making your own formulas is kind of complicated, but all the practice set is saying, is this geometric or arithmetic? And then also looking at finding what the common difference is, that kind of thing. So we should be good to go there. Please work on that. Bring that to class with your notes tomorrow. See you then.